Welcome to this explainer. Today, we're diving straight into the NCP-MCI 7.5, Objective 3.5, VPCs and the Flow Virtual Networking Overview. We're going to systematically break this all down to get you absolutely ready for your Nutanix certification. So, if you're an infrastructure admin looking to completely ace this exam, you are in exactly the right place. All right, here's our study roadmap for the day. We'll kick things off with why virtual networking actually matters, then get into the nitty-gritty of VPCs and overlay networks. After that, we'll look at some real-world examples, dive into VPNs and Layer 2 extension, highlight some common exam traps you need to watch out for, and finally wrap up with the absolute must-memorize facts. Part 1. Why virtual networking matters and how we're moving beyond physical switch constraints. So to really get the mechanics here, we first have to ask ourselves, why are we even moving away from those traditional, rigid, physical VLANs in modern data centers? Well, Flow Virtual Networking, or FVN, is the answer. It's an add-on solution, and you'll definitely want to remember for the exam that it is strictly enabled and managed through Prism Central. It's all about that flexible, app-driven networking. And the big takeaway? FVN completely abstracts your physical network. You are no longer handcuffed to traditional VLANs or the IP constraints of your physical switches. It is software-defined through and through. Moving on to Part 2, VPCs and overlay networks, the absolute core of FVN. Let's break down the actual building blocks of this software-defined approach, looking specifically at the overlay networks running right on top of your physical hardware. As an admin, when you're setting this up, think of a virtual private cloud, a VPC, as a completely isolated, secure bubble for your virtualized workloads. It is literally the fundamental unit of Flow Virtual Networking. Inside this isolated network namespace, there's a virtual router instance connecting all your internal subnets together. This gives you security by default, and it completely isolates your virtual traffic from the underlying physical network. Now, the real magic here happens with Geneve encapsulation. This is what decouples your virtual network from physical constraints. It allows packets to tunnel seamlessly between different hosts. Imagine two VMs in the exact same VPC, but sitting on entirely different physical hosts. When they need to talk, the host just encapsulates those packets in Geneve, sends them across the physical network, and the destination host decapsulates them. It's actually brilliant because it means your top-of-rack switches don't even need to know these subnets exist at all. Let's peek under the hood at the exact packet flow. It all revolves around a software object in the host kernel called a representer port. When a packet leaves a VM, it hits that host kernel first. Then, the representer port steps in, acting as this crucial bridge between the VM and the physical network interface card. After that, the Nutanix network stack does a flow lookup. If you want to nail this on the exam, drill this into your head. It is the representer port that handles this routing in the Nutanix network stack. All right, Part 3, real-world VPC examples and how this actually applies in the field. So we've covered the what and the how. Now let's ground this in reality. We're going to look at two highly testable, concrete deployment examples. The exam absolutely loves throwing scenario questions at you based on why you'd even want to deploy a VPC in the first place, so keep your eyes peeled for these two powerful use cases. First up, overlapping IPs. Think of it like apartment numbers in different buildings. Multiple isolated VPC tenants can all use the exact same apartment 101 internal IP address, and their traffic will never cross paths. Because each VPC is its own isolated namespace, tenant A and tenant B can spin up subnets using the identical IP range. The Geneve tunnels and the isolated virtual router make sure those packets never collide. If you're a service provider or a massive enterprise doing multi-tenant provisioning, this is an absolute game changer. The second major use case is disaster recovery, specifically pilot-light deployments. Say a failover event happens. Nutanix Disaster Recovery can dynamically spin up these required VPC networks in the Nutanix cloud, even if you hadn't set them up beforehand. You just replicate your snapshots to cost-effective object storage, and then, if disaster strikes, you spin up the compute and restore right into those dynamically created VPCs. You get this incredible hybrid cloud agility, but you aren't stuck paying for idle compute nodes just sitting around waiting for an emergency. Moving on to Part 4, VPNs and Layer 2 extension, connecting the clouds. Okay, as we start scaling out into hybrid cloud architectures, we obviously need to securely connect these isolated VPCs to the outside world. That means standing up gateway connections. Now pay close attention to the strict requirement here when you're establishing an eBGP peering session over an IPsec tunnel. When you connect your on-prem VPN gateway to a Nutanix Cloud VPN gateway, they establish that IPsec tunnel. And over that tunnel, they use BGP2 exchange routes. Look closely at that bottom row, the ASN role. I promise you the exam makers love testing this specific detail. Here is the golden rule. The Autonomous System Number, or ASN, for your on-prem gateway must not match the Nutanix Cloud Gateway. If you don't already have a BGP environment running on-prem, you can honestly just pick an arbitrary number in the 65,000 range, as long as it's unique. But whatever you do, do not let that on-prem ASN conflict with the Nutanix Cloud Gateway ASN. If they match, your peering session fails, your routes won't exchange, and it's game over. Next up is Layer 2 virtual network extensions. This is an awesome feature that lets a subnet span across entire clusters, using either VPN or VTEP services. Basically, it allows VMs to communicate exactly as if they're on the same local network, even if they're actually spread out geographically. By using a VPN or a VTEP, which stands for VXLAN Tunnel Endpoint, you can stretch an overlay subnet right across availability zones, or even to a third-party data center. It is an absolute lifesaver for application migrations, where you literally cannot change the IP addresses of the servers you're moving. All right, Part 5, Common Exam Traps. Consider this high alert territory. Listen up, because you need to memorize this exact distinction between intra-cluster bro traffic and external traffic that hits the physical switch. East/west traffic stays strictly inside the VPC. It is Geneve encapsulated, and it travels entirely on that internal host port, bro. North/south traffic, on the other hand, is crossing the boundary. It's ingress or egress traffic, entering or exiting the VPC, and it's governed by the external VLAN. The exam will try to trick you with scenario questions, so do not let them mix these two definitions up in your head. Let's test your knowledge on permanent configurations inside AHV network management. Take a second and think about this scenario. You create a network, and a week later, you realize you need to change its state from managed to unmanaged. What's the process to do that? Give it a quick thought. The answer is, you can't. Lock this into your memory right now. It is absolutely impossible to toggle a network's managed state once it's been provisioned. The Nutanix architecture completely restricts this. If you mess up during deployment and choose the wrong one, you literally have to create an entirely new network from scratch. No exceptions. Here's another trap. If you need to reconfigure a VM's network assignment, you cannot just change the VLAN subnet or update the VLAN ID directly on a VM's VNet. You have to delete the existing VNet and create a brand new one. Now, there is a tiny bit of nuance the exam might use to trip you up. While you technically can change a legacy VLAN basic subnet on a VNet, you absolutely cannot change a newer, advanced VLAN subnet, and you definitely can't update the VLAN ID directly. So the rule of thumb? Delete and recreate. That is the Nutanix way. Finally, Part 6, Key Facts to Memorize. Let's do a rapid review. Let's bring all this complex architecture together into a few must-know takeaways. Take a mental screenshot of these points. First, Flow Virtual Networking is a Prism Central game. It is managed purely via Prism Central, not Prism Element. Second, VPCs use Geneve encapsulation to completely bypass those top-of-rack physical switch limits. Third, never forget those representer ports living in the host kernel that route VM to NIC communication. And lastly, double and triple check that your on-prem and cloud eBGP ASNs are different. Understanding these VPC concepts doesn't just get you ready to crush the exam. It genuinely transforms how you build resilient infrastructure in the real world. By decoupling the physical network from your applications, you're unlocking incredible hybrid cloud agility. So, are you ready to ace the NCP-MCI 7.5? I know you are. Thanks for hanging out with me for this explainer, and best of luck on your certification.